Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Chapter 2, Projection Section Perspectivity, Elementary Configurations. Section 17, Perspective Tetrahedra. As an application of the corollary of the last theorem, we may now derive a theorem in space analogous to the theorem of Desargues in the plane. Theorem 2. If two tetrahedra are perspective from a point, the 6 pairs of homologous edges intersect in coplanar points, and the 4 pairs of homologous faces intersect in coplanar lines, i.e., the tetrahedra are perspective from a plane, assumptions A and E. Proof: let the two tetrahedra be P1, P2, P3, P4, and P1', P2', P3', and P4', and let the lines P1, P1', P2, P2', P3, P3', P4, P4' meet in the center of perspectivity O. Two homologous edges, Pi, Pj, and Pi' and Pj' then clearly intersect. Call the point of intersection Pij. The points P12, P13, P23 lie on the same line, since the triangles P1, P2, P3, and P1', P2', and P3' are perspective from O, by Theorem 1 corollary. By similar reasoning applied to the other pairs of perspective triangles, we find the following triples of points are collinear: P12, P13, P23, P12, P14, P24, P13, P14, P34, P23, P24, P34. The first two triples have the point P12 in common, and hence determine a plane. Each of the other two triples has a point in common with each of the first two. Hence, all of the points Pij lie in the same plane. The lines of the 4 triples just given are the lines of intersection of the pairs of homologous faces of the tetrahedra. The theorem is therefore proved. Theorem 2'. If two tetrahedra are perspective from a plane, the lines joining pairs of homologous vertices are concurrent, as likewise the planes determined by pairs of homologous edges, i.e., the tetrahedra are perspective from a point, assumptions A and E. This is the space dual and the converse of Theorem 2. Exercise: write the symbols for the configurations of the last two theorems. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.